Question 4 is saying a ball B of mass 1.2 kilograms traveling at constant velocity collides head-on with a stationary ball S of mass 3.6 kilograms as shown in figure 1. So this is figure 1. And the question continued to say frictional forces are negligible. The variation with time t of the velocity v of ball B before, during, and after collision with ball S is shown in figure 2. So this is the graph that is showing us the relationship or the activities, the changes in quantities that took place on ball B during its collision with ball S. So this is only about the second ball B. So use figure 2 to determine for the ball B during collision with ball S. 1. The change in momentum of ball B. 2. The magnitude of the force acting on ball B. 3. Calculate the speed of ball S after collision. And 4. Using your answer in C and the information from the figure 2, deduce quantitatively whether the collision is elastic or inelastic. So what information are we supposed to get from here? We know to say in order for us to calculate the change in momentum or the force, we need to know the velocity, the initial velocity, and the final velocity on ball B, since this graph figure 2 is showing us the characteristics of ball B. So from here, what are we going to get? The initial velocity, we can get it from here. We can see to say the initial velocity of ball B before collision was positive 4 meters per second. Then it collided with this object at this time interval. It collided with ball S from that time, and they were in contact until this time here. And by the time they were not in contact anymore, the velocity of ball B was just slightly above -1, of which in this case, this is negative 0.8 meters per second. So that means this is the final velocity of ball B, while still this is the initial velocity of ball B. And we are supposed to also deduce from this graph the time in which the two balls were in contact. So from here up to there, using the scale to which this graph was drawn, the time was actually going to give us 0.08 seconds. Using this scale, if we deduce the time from this scale here, in the horizontal axis, we're going to find that the time in which the two balls B and S were in contact during collision was just actually equal to 0.08 seconds. And if we have these three things, I believe we can now get on with our calculation. So let's go to our blackboard. This is question 4. Okay, so this is question 4, and we have ball B, and we also have ball S here. So I know to say the mass of B is 1.2 kilograms, whilst the mass of S is 3.6 kilograms. We also know to say the initial velocity V0 of B is positive 4.0 meters per second, whilst the initial velocity of S, or maybe let me first write the final velocity, V final of B is negative 0.8 meters per second, whilst the initial velocity V0 of S is equal to 0 meters per second, whilst the final velocity we don't know. The only thing we know is the time in which these two objects were in contact, of which we found to say this is 0.08 seconds, like this. Okay, so now we can get into our calculations. to say we should calculate the change in momentum of ball B during collision with ball S. So the change in momentum of B will be equal to what? It will be equal to the initial momentum, or the final momentum rather, minus the initial momentum. And this is equal to what? Since the mass of B is constant, we're going to have M V final minus V initial. This is going to give us how much? The mass of V, let me write it here in the beginning. The mass of B, which is in this case 1.2 kilograms, multiplied by the final velocity, which is negative 0.8 meters per second, minus the initial velocity, which is 4.0 meters per second. Okay, so this is giving us 1.2 kilograms. Then in brackets, we have negative 0.8 minus 4.8. We're going to get negative 4.8 meters per second as the change in velocity. Okay, so from here, we multiply 1.2 kilograms by negative 4.8 meters per second. And this is actually going to give us the change in momentum of B to be equal to negative 5.76 kgs meter per second. So this was the change in momentum of ball B. And but B is saying we should calculate the magnitude of the force that is acting on B. The magnitude of the force that is acting on B. We know to say average force multiplied by change in time, of which in this case this is the time that the two objects are in contact rather, will be equal to the change in momentum. So that means our average force is equal to change in momentum divided by the change in time. So average force here will be equal to the change in momentum, which are from calculating to say negative 5.76 kg meter per second divided by the time interval in which the two objects were in contact, which is 0.08 seconds. Okay, so negative 5.76 kg meter per second divided by 0.08. This should give us negative 72 newtons. That means the average force acting on ball B is 72 newtons, but acting in the opposite direction to the initial positive motion. So that is the magnitude of the force that is acting on ball B. Okay, part 3 is saying we should calculate the speed of the ball S after collision. So the speed of S after collision. Speed of S after collision. So how are we going to calculate the speed of S after collision? We're just going to use the principle of conservation of momentum, which means the initial momentum should be equal to the final momentum. So I'll say MB V initial of B plus MS V initial of S. This should be equal to MB V final of B plus MS V final of S. So this is the guy that we are looking for. Okay, from here we can actually start plugging in. Notice that the mass of B is 1.2 multiplied by the initial velocity, which is in this case 4.0 meters per second, plus the mass of S, which is 3.6 kilograms, multiplied by the initial velocity of S, which is in this case 0 meters per second. Okay, this will be equal to, so this guy is already a 0, so I can just take it out to reserve some space. Okay, so that means this part is equal to 1.2 kilograms multiplied by the final velocity of B, of which the final velocity of B is negative 0.8 meters per second, plus 3.6 kilograms multiplied by the final velocity, which is V final of ball S, that we don't know yet as of now. So we multiply this guy that is here, we're getting 4.8 kilograms meter per second, being equal to 1.2 kgs multiplied by 0.8 meters per second, we're getting negative 0.96 kg meter per second plus 3.6 kg V final of S. Okay, from here, what do? We can just arrange the equation that we have and make V final S a subject to the formula. So I'm going to have 4.8 kg meter per second plus 0.96 kg meter per second. This will be equal to 3.6 kg V final of S, like this. So if I add 4.8 plus 0.996, I'm getting 5.76, of which this is in kgs, kg meter per second, being equal to 3.6 kgs V final of S. So I'll divide both sides by 3.6 kgs. This will cancel out. Even here, I'll divide by 3.6 kgs. The kg and the kg will cancel. That means the V final of S, the ball S, was equal to 1.6 meters per second. So the final velocity of ball S, which was initially at rest, was actually 1.6 meters per second. Question 4 is saying, using your answer in C and the information from figure 2, deduce quantitatively whether the collision is elastic or inelastic. So we're back again on uh, predicting whether the collision was elastic or inelastic, of which we said we're just going to be comparing the kinetic energies, whether the momentum is conserved and also whether the kinetic energy is conserved. If there's loss in kinetic energy, that means the type of collision that you're dealing with is actually an inelastic collision. Okay, so let's now check the kinetic energy. To say when the collision is elastic, Ke initial should be equal to Ke final. So what about Ke initial? What do we have? We have half mv squared of B, this is initial, plus half mv squared of S, and this is also initial. I have half 1.2, then I have the initial velocity, which is 4.0 squared, plus half 3.6. The initial velocity of S was 0. So that means I'm having that, which means this is taking out this part of the equation, and I'm remaining with half 1.2 multiplied by 16. This is going to give me the total initial kinetic energy, Ke initial, to be equal to 9.6 joules. That means the initial or the total initial kinetic energy was actually equal to 9.6 joules. Now let's check the final kinetic energy of the two objects. Let's say KE final will be equal to half mv squared final of B plus half mv squared final of S. So this is giving half 1.2. The final velocity of B was negative 0.8 squared. I have plus half 3.6. The final velocity we've just calculated to be 1.6. 1.6 squared, like that. So from here we're going to deduce. We have half 1.2, 0.08 squared is going to give us 0.64 plus half 3.6 multiplied by 1.6 squared, which is going to give us 2.56, like that. And if we plug these into our calculator, we should be able to get a total of kinetic energy, KE final, which is equal to 4.992 joules. Okay, so if you compare the initial kinetic energy and the final kinetic energy, you can conclude to say there was kinetic energy that was lost. A significant amount of kinetic energy was lost in the process of the collision. And what does that mean? That means the collision wasn't elastic because kinetic energy wasn't conserved at all, which means this type of collision is actually inelastic. Okay, so that is confirmation of tutorial sheet 10. This was the last question, question 4. Thank you very much for watching once more. Subscribe to our channel, register to our academy at discretelearning.com, like, share, and stay blessed. Thank you very much.